been quite some time since my last upload, 12 days ago, but well. So, for this video today, we're gonna talk about radicals and its mechanism. So, we know that if you treat some kind of an alkane with some molecular halides, you will get the halogenated alkane, right? Using light as the kind of a catalyst, as you could say that. But yeah, so today we're gonna look at the mechanism of the radicals and how this kind of reaction goes. So for the first step is initiation. Radical reactions. Initiation. Did I spell that right? I think that's how you spell the word initiation. So for every radical reaction, there will be 3 steps: initiation, propagation, and termination. For the initiation step, so we're going to generate a species of radical. So we're going to generate a radical, right? So for this reaction, when the bromine molecule is hit with light, the BR-BR bond will break in a homolytic way. So it will break and give 1 electron to the bromines. So you will get 2 bromine radicals, right? Well, I'm just going to write 1 here then. So you will get a bromine radical or 2 bromine radicals. So this is how the initiation step goes. Then what's going to happen next is that the propagation step will follow, whereby your bromine radical and your starting material, so the bromine will grab one of the protons this way, and then you will get a radical on the alkane right here. Then it's going to come in contact with another bromine molecule and grab one of the bromines to get your final product. And you also get another bromine radical in the process. As you can see, you also get another bromine radical, which is recycled for another propagation step. So it is very useful, and you can have this reaction go on and on and on and on. That's why they call radical reactions as chain reactions, because you can have another radical and then come into contact with another radical, and then the reaction just goes so on and so forth. And then the last step is termination. So termination is just the step where the 2 radicals recombine. So, oh sorry, not a 5-member ring, a cyclohexane rather. I'm a bit sick. Combine to give you something, really, because radicals, they have ways of combination that they want. They can self-combine like this. So maybe if you have 2 cyclohexane radicals, you can have 2 of them reacting with each other and get your product. You can also have your bromines coming back. You can also have them come back and form molecular bromine once again. So yeah, this is really the step of radical reaction. So we have 3 steps: initiation, propagation, and termination. So let's look at the second example I have prepared. So we have a bromocyclopentane reacting with tributyl hydride. This is called a tributyl hydride with AIBN to give you your cyclopentane. what is AIBN? AIBN is a radical initiator. You can think of it similar to light. So it's going to be similar to light because it does the same thing. It will generate radicals. All right. So what's going to happen first is that your AIBN, which looks like this. So the first step is, of course, the initiation step. So this is AIBN. This is how it looks like. So the first step is the generation of radicals, right? So this will happen to form two of these radicals and nitrogen gas. Might as well be consistent and put 2 right there. All right, and nitrogen gas, which is, as you know, it's the best entropy booster. So that's your initiation step. Then what's going to happen next is that your radical that we have just made will interact with your tributyl tin hydride and form the tin radical. So this is the formation of your radical. Then the propagation step. So we have the haloalkane, right? Which is, in this case, is a bromocyclopentane, come into contact with the tin radical. Same thing follows is that you get the alkane radical, and then another molecule of tributyl tin hydride comes into the reaction, grabs one of its protons. Grabs its only proton, right? I should say hydride, to give you the cyclopentane, right? And another tin radical, which can, of course, recycle back into this reaction. Might as well write as the SN. Okay, so that's the byproduct. Yeah, so as you can see, it's the same thing, right? Propagation step must have a radical that's being generated, which can be used again or recycled back again to continue this reaction, to continue this chain reaction. And the termination step is just the recombination of radicals, right? So it could be 2 of the cycloalkanes coming together. So you could have this, you could have whatever. You can have a million possibilities with the termination step, given that there's a radical in your system. But the termination step is kind of not really that important to us, because the step that is important to us is propagation step, because this is how you get your final product, and this is how you continue your reaction by generating a radical which can be recycled again, right? And furthermore is that radical recombinations are quite rare, actually. In fact, radical recombination are quite rare compared to radical with another molecule. So as in right here, radical with another molecule happens very often, more often than radical. So yeah, and that's pretty much all I want to talk about today about radicals. Thank you for watching.